So thank you everyone for coming today to my talk about functional Kotlin with Arrow. I am so happy to participate in the meetups again, even if they are online. So let me introduce myself a bit. My name is Karin. I'm a senior software engineer, and I have background in your favorite languages, in Scala and Kotlin, especially Kotlin, and even on front end. So I have a lot to talk about, but today we are going to talk about functional Kotlin. So currently I'm residing in Berlin, so I'm here in Brighton remotely, which I could visit it someday. And yeah, I have 2 cats, and you can follow me on Twitter, GitHub, and any other social networks by the nickname listed on the slide. So let's begin then. So today we are going to talk about very basic stuff. So like no pure functional programming, just solving tiny problems that every or most of the software engineers can find in almost every single project. So since we're talking about Arrow, we will talk what is Arrow, about the basic structures like NonEmptyList, maybe a bit more advanced structures like either and its friends, and such an interesting concept as Monot comprehensions. So in Kotlin, there are already some elements of functional programming like read-only collections with various functions like map, filter, any, vals, and also there are functional types. And Arrow adds to this functionality. Actually, Arrow consists of multiple parts. So core, effects, optics, and meta. So core is basically more functional programming. Effects helps you to compose asynchronous and concurrent programs. Optics will help you when you have to deal with nested structures and you have, for example, to update a field in a deep nested object without doing copy, 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 and copy. And meta is something more advanced stuff, which enables you to write compiler plugins, linters, and such. But today, we're talking about basic things, especially about Arrow core. So let's take a look what we have in Arrow core. Let's start with NonEmptyList. Imagine we are going to build a shop. So like as every single shop, we accept some kind of payments. Payments are described described as follows. So it's an array of various fields which are partially required and partially not. But my question is here, if we get a JSON with payments as an empty array, is that okay? So from the software engineering standpoint, well, sure, why not? An empty array and an empty list is just a regular list, just empty. So sure, why not? But to be honest, from the domain and business standpoint, that doesn't really make sense. So we can restrict it using NonEmptyList off. NonEmptyList off is pretty straightforward. So if you pass no arguments to its constructor, so it just won't compile. In case you pass something, it will work just fine. So like in this example, you can see a NonEmptyList of integers. So that just works. What's nice, Arrow has integrations with JSON already. So you can, if you use JSON on your project, in your project, it will work just fine, just like out of the box. So sounds easy, isn't it? So let's take a look at something more advanced. It's called either. But first, let's take a step back to Java. Yeah, this is a big step back, but yeah. So not every time everything is perfect. And sometimes we should or want to handle or show some kind of errors when something gets wrong. So before Kotlin, let's take a look to a Java way. So typically, when writing something in Java, we will write something like this. So if something wrong, throw some exception, and then mark this in this method signature that this method will throw some exception. Then somewhere else, we will write our try catch finally and handle it. So this works, and this works just fine. So sure, why not? The issue here is, for example, sometimes you're just forced to handle exception even when you're sure there will be nothing wrong. But the most important here is, sorry for my cat, he is a co-host today. It's just inconvenient to use such a big structure like try catch finally in some APIs. For example, in Java Stream API. Let me show you. So imagine we want to run a test function that throws some exception multiple times using Stream API. You will write something like this, and it looks great. But to be honest, this won't work. Why? Because our test function throws exception, and this exception is checked. So you can actually put try like right here for each block, but well, this won't look really great. So a typical approach to this problem will be to write wrapper with try catch somewhere else, and for example, let's call it hide exception, and this wrapper will wrap a checked exception to an unchecked exception, so it will pass just fine. But now, this doesn't sound really great from the type system standpoint, because it won't tell us about the possible errors on the compile time right here. So to compensate this, a typical approach here will be undo this wrapping of the exception back to checked exception somewhere outside. So let's do unhide some exception. The problem here is, yeah, this works, but this may be not so obvious and not so beautiful, because, yeah, like now, instead of just in-stream range for each, you have two wrappers, and also one may produce an error when, for example, doing mapping from hide to unhide wrong, and because you may forget some cases here and such. Okay, let's take a look at Kotlin. So in Kotlin, like in most or maybe all JVM languages, there are no more checked exceptions. So if you will rewrite the previous function to Kotlin, you will write just something like this. So it's better to write it via repeat, but for the sake of consistency, let's stick with this one. Yeah, this will work out of the box. Your ID won't show any errors and such. But the problem here is we want to know about possible errors and error flows, and we want to show them. So let's take a look at the standard library. How do they handle those cases? So typically, you may find a plain and simple approach and pretty type safe compared to Java with nulls. So for example, take a look at the function from the standard library. So extension function to int or null, which will return you an integer when the string is parsed correctly to integer, or null if anything will go wrong. Well, this works, and it's supported pretty good by a standard library. For example, there are null safe calls and Elvis operators, so it works just fine. The problem here is like your code becomes questionable because a lot of question marks. So that's not a problem per se, but the most important thing here is the code is not so expressive. So for example, if the parsing of the string to integer failed, we don't know exactly what was wrong. So were there an integer overflow, was the string incorrect or something? We are just guessing null. Let's take a look at the standard library again to check if there's anything else which may help us. Well, there actually is. It's called ResultType. So the ResultType is either some type T or exception. What is interesting in ResultType, there are functions to create chaining. So for example, run caching, recover caching. So you won't get deep nested try-catch chain, and it's readable. But looking at this one, to be honest, you still have no info on compile time, at least no more than from now. Also, also run caching may be way too greedy for you, but that's another problem. So what can we do here? We can do seal types. So if there is a subset of the things that your function can result in, you can just list every single outcome here. So in a seal type. For example, imagine we want to trade some stocks, and we definitely know that there will be only 3 possibilities what may come afterwards. So either we will trade our stocks successfully, so success, or the stock market will crash because the moon was, for example, too full, or Elon Musk tweeted something which crashed the stock market. And this approach is really nice if you can list every single possible outcome. So this is interesting. Also, what's interesting here is in a lot of situations, you can list as a result some success and some failures. And this pattern is called either. In Arrow, there's also a class either, which has which can be left or right. The mnemonics here is the value on the right is right, so right is right, and on the left side you will store some failures. For example, right on the right will be success, and on the left there could be full moon failure. So what is interesting in this class, there are functions like map left, Flatmap, but a bit later about that. In Arrow, there is also a neighboring class called validated, which has a similar structure. So validated can also have 2 outcomes, invalid and valid. So the difference here is how do you use it? So for either, typically it will stop on the first invalid value, and validated will collect them all. For example, if we validate the user for either here, there will be a failure of invalid phone, and validated will tell you that the phone name and age are invalid. Here, a tiny remark: please be mindful when you validate names, because even my name is invalid at least once per month in various services. So your assumption about the names may be wrong. You can check the link on the slide to read a great article about that. So the third class that looks almost the same is called IOR. It can be left, right, or both. You can use it for tasks, for example, when right is a pure success, left is something is completely wrong, and both is like, yeah, this value is somewhat valid. We can allow this, but let's issue a warning. So, for example, something like that. So let's go to the scary part of the talk called Monot comprehensions. Most of you actually already saw something Monot-like. So let's not talk about like academic definitions of that, and define a monad as a structure that has three methods: create, map, and flatmap. So for example, most of you already worked with lists, which have list of, map, flatmap. So for example, for iterables, flatmap in Kotlin is defined as follows. So as I mentioned before, either also has such functions. For example, map and flatmap. And actually, this is something that we can use for either type. Flatmap is working as follows. So if the first value is right, we continue our chain of flatmaps, and we are continue doing this until we reach the end of our chain and return a value, or we meet a value of left. In that case, we will stop and return left. Yeah, for example, imagine we are building a web page with some information about stocks. Let's take a user, the stock info, and historical data using the function getFromDB, which returns either of some kind of error response and t. And we can chain it as follows. One can say, well, this doesn't really look so great because when we are doing flatmap, and flatmap, we are getting more and more nested structures, and it's hard to read. Actually, this problem is solved for the most popular monods, like either options. It's called monod comprehension. So we can rewrite the previous code like this. First, we are defining our either block. A small note here, the syntax of monod comprehension was changed. I think this is the most recent one, but you may find other types of syntax, which instead of either has either.fx. So here, every single method that we are calling is returning either. And as you can see, there is a special function bind, which will return the result that we can use. For example, we can write it to variable and continue. So here, we also, if the user was retrieved correctly, we will get a user. If then we are going to collect stock info. And for example, if here something was wrong and either was left, we stop here, and the result of our comprehension will be left. And that's basically it. So the next steps for learning Arrow are learning about more classes from the core. Actually, we covered a lot of them, but I recommend to take a look on option. So there's value or there's no value, on eval that controls evaluation of value, on multiple extensions to the standard library like zip, unzip, more folds like fold left, fold right. Then you can go to the FX, learn the concept of suspend in Arrow. learn about parallel execution, for example, parzip, partraverse tracing, and then take a look at optics to learn how to work with immutable objects and avoid making copy when you want to copy an object with a single field changed. And yeah, that's it for the overview. Thank you for coming today and listening to the talk. Please, if you have any questions, feel free to ask them.
Thank you, Karin. That was really interesting. I've got a question myself, actually. The whole arrow concept is pretty new to me. I only work mainly on the back end, kind of Spring Boot, that kind of thing. Do you think that arrow is applicable to kind of like one area more than another? Like, is it applicable to any project, or is it more back end, or is it more mobile? What do you think?
I don't really have a lot of experience with Kotlin on mobile phones, but I can assure you we have projects of using Spring and Ktor, and everything works just fine. And I think that every project has place, for example, for either for better readability. So yeah, I think for backend, every single project would work with arrow, even if it's new or if you adapt the existing one.
Awesome. So in the chat, we've got, could you recommend any good resources where people can learn more about arrow?
Yeah, sure. So if you go to the, for example, maintainers website, there are a lot of talks collected here. And also, I think 47 Degrees, pretty sure they have an Arrow Academy if you have knowledge of Kotlin, so at least you can understand how to use suspense. I think this is like the base level. I highly recommend this course for deeping dive to the Arrow core and Arrow effects and optics. It's pretty good covered.
Awesome. So I guess one last one. You mentioned that suspend has another meaning in Arrow compared to Kotlin. What could you kind of elaborate on that a little bit more?
Yeah, in FX there is a bit different like interpretation of the suspend. So like in Kotlin, suspend function can be called from another suspend function. It's also true for arrow FX, but the thing here is a suspend function in arrow FX are marked the function that have side effects. So a side effect is something like when you call a function and, for example, a state of some object gets implicitly changed. So, for example, typically any I/O operation, for example, call to a database or like printing logs. So yeah, that's basically it. So yeah, every function with side effect is a suspend function here.
Excellent. Another question in the chat is, how far is Arrow from 1.0?
That's a good question, how to define the maturity of the project. So I think the actual version is 0.13. I'd say it's pretty stable to use on production, and we use it in, I think, most of our projects in our department. But yeah, I'm not really sure what this question should mean. So I can assure you it's stable enough to use. So for example, arrow meta isn't stable enough for using on production because the API, a compiler API, isn't stable, as I remember correctly, but arrow core effects and optics are, can be used.